All right, the other major tidying task that we will have to do that is very common is merging data, also known as joining data. So it's very common that you'll need to link two data sets together based on some shared keys. So let's say, for example, we have two data sets. One has information on a person and how much income they earn in a given year, and the other data set has information on where that person was born, their birthplace. So here we have the person year data. We have Ramesh in 2014 earned 81,000. Ramesh in 2015 earned 82,000. Whitney in 2014 earned 131,000, and so on. Right? We also have this birthplace data. We see that Ramesh was born in Crawley and Whitney was born in Washington, D.C. So we have these two data sets, and let's say that I want to do something like, say, see how income varies based on your birthplace. Well, I'd need to get birthplace and income into the same data set, and how can I do that? So we've seen what our data looks like. It looks like these two things. We thought about what we want it to look like. I basically want this data set, except I want another column called birthplace, and I want it to be Crawley for Ramesh in both of the rows here, and I want it to be Washington, D.C. for Whitney in both of the rows here. How about David? We don't have David's birthplace. Well, we'll figure that out in a bit, but now we know what we want it to look like. So in dplyr, the join family of functions will do this for us. There's a bunch of different join functions, basically what they do is they take those, they line things up. What we're going to do is we're going to tell it the names of the key variables that are shared between these two, right? So we have the key variables, the identifying variables here are person and year, and here it's just person. They share the person column, so I can use join to sort of line things up. What the join function is going to do is it's going to say, okay, I've got this data set here. I've got this data set here. I'm going to join these two together. I know that I'm working on a shared column of person, right? That's what I'm looking for. So I'm going to say, okay, I want to attach some values over here for Ramesh in 2014. Ramesh has a person name of Ramesh. I look in this data set and I say, oh, okay, Ramesh is right there. So that lines up. That means I'm going to take this value and I'm going to stick it right here. Move on to row number 2. Ramesh again. Okay, look over here. Okay, here's Ramesh. Crawley again. Okay, I'm going to put Crawley here in the second spot. And the same for Whitney. Here's Whitney. Look over here for Whitney. Okay, Whitney is Washington, D.C. Stick Washington, D.C. right there, and so on, right? That's what the join functions do. They line things up based on the shared key variables, and they bring in the new data that lines up. And sometimes it multiplies things. It duplicates things when it needs to. So Ramesh has 2 rows here, but only 1 row here. So Crawley's going to it's going to get matched twice, basically. And that is part of what merging does. Now, I mentioned there's a bunch of different varieties of merge, and the only way that they really differ is by what they do when you don't find a match, right? So I mentioned we have David here who does not have a birthplace listed. So what am I going to do with David? Is David going to stay in the data but have a missing value here because I don't know what David's birthplace is? Is David going to get dropped from the data because I only care about people I can find a match for? Lots of different options. So that's what the different varieties of join are for. So left join will keep non-matching rows from the left data set, or from the first data set you give it, but not the second. Right join will keep non-matching values from the second, but not the first. Full join will keep everybody, whether you find a match or not. Inner join will not keep anybody's match, anybody who doesn't find a match. Inner join will only keep things that did find matches. And there's also anti-join, which just keeps the non-matches, which you probably won't have to use, at least in this course. So here's how this can work. I'm going to take my person year data. I'm going to pipe that to left join. I'm going to join it with person data. And I'm going to say, hey, you're joining on the key variable person. And it does exactly what we wanted it to do, right? It says, hey, here's Ramesh. I filled in Ramesh's birthplace with Crawley. Same thing here. Same thing for Whitney. Same thing for Whitney. And then David doesn't have a birthplace. So it's like, okay, well, we're missing a match. What do I do with a non-match? Well, this is a left join, which means that if a value is in the left data set, the first one I give it, then it stays in even if it doesn't find a match. But if it's in the right data set, it doesn't. So David is in the left data set. He's in the person year data. So he stays in even though he doesn't find a match. And so we just fill in a missing value for the birthplace because we don't have it. On the other hand, if we did a right join, the right join keeps non-matching values from the second data set we give it, but not the first. So that means it's going to keep non-matched values from person data, of which there aren't any. Right? Everything in person data gets matched. Whereas David, who is in the first data set, he's not going to get kept because he didn't find a match. So David does not end up in this data set right here. Some notes about merging data. So that is what merging data is all about. You just take the two data sets, hope they line up, and then you join them together, and you decide what you're going to do with the non-matches. Now, an important key point about merging data is that things work great with merging data as long as the set of variables you're merging on is the exact observation level in at least one of the data sets. You're going to run into problems if you have multiple copies of a observation on both sides. So what do I mean by that? So if we look back at our data here, notice that we're joining on the person variable, right? And Ramesh shows up twice. Okay, so what happened when we joined things together? Well, Ramesh still shows up twice in this data, and we assigned the single birthplace that we had for him of Crawley to both of those observations, right? And this works because Ramesh is only in here once, right? So what would happen, though, if I listed two different birthplaces for Ramesh? What would happen? Well, we'd go to join, and it would say, okay, we got this Ramesh data value over here. We're going to see what that lines up with on the right side. We got Crawley, and let's say we somehow listed both Crawley and London for Ramesh. Well, then which one would it get? Would this become Crawley, or would this become London? And what it typically tends to do is it just says both. And what we'd end up with is we'd end up with one row of Ramesh 2014 in Crawley and one row of Ramesh 2014 in London. And now suddenly we don't have our key variables working anymore. We've duplicated some values. So we want to make sure that whatever variable we are joining on, in this case person, uniquely identifies the observations in at least one of the data sets. If there's only one row if there's only one person row in both of the data sets, that's fine. You just line them up. If there's multiples in one data set, that's fine. You just duplicate what we have, like we did here. We got Crawley and Crawley. But if there's duplicates in both, what are we going to do, right? We don't want to do that. So generally, you want to avoid that. So here's an example of what happens. So here I've made a data set using the Tibble function. Here's your name. We got two A's, a B, and a C on the left, 2014, 2015, 2014, 2014 as years, and then values of 1 through 4. Here on the right, we've got names A, B, C, C with some characteristics, and I want to join these two things together. Now, if I join these together by their name, notice that there are duplicate A's on the left and also duplicate A's on the right. And what do we end up with? Well, we only had 2 rows of A in each case before, but now we have 4 rows of A because it said, okay, I've got a 2014 and 2015 over here. I've got an up and a down over here. I don't know which ones joined together exactly, so I'm going to go ahead and just do all the combinations that I have. So I'm going to get one up, a 1 down, a 2 up, and a 2 down. This probably is not what we wanted to happen. So it's very important to check the observation level of your data to make sure that you are right about what you think your observation level is. A good way to do this is to see if there are duplicate rows among your key variables. So what do I mean by that? So we pick our key variable. So in this case, maybe our data set is we're joining on person. Right. So if I see Ramesh twice, that means that this is not the observation level for this data set, right? Because I should only get 1 row per combination of key variables, right? So if there's any duplicates, then that means it's not that we have not fully gotten the key variable list, which makes sense here because our key variables here are person and year, not just person. Over here, though, there's only 1 row for Ramesh and 1 row for Whitney, so person is our key variable there. So we can detect whether we've properly figured out the key variables by seeing whether there are any duplicates of rows when we just look at those key variables. So we can do that by taking our data set, selecting the variable that we're going to join on, checking if there's any duplicates, and then taking the maximum of that. And this will tell us, this will give us true if there are any duplicates, or 1. It will give us 0 if there aren't any duplicates. If it gives us 1, that means that we are wrong about what we thought our observation level was, right? So if I take this code and I apply it to this data set, it will tell me, yes, there are duplicates because Ramesh shows up twice. And then I would check this other one, and it would tell me, no, there's not any duplicates because Ramesh only shows up once. And that'd be fine because there's no duplicates in at least one of them. That's what we want. So if we do have duplicates, we can think about what we're going to do at that point. Do we drop observations so there's only 1 left? Do we accept the multi-match? Hopefully not. Maybe pick only one of the multi-matches. There's some choices to make if you do find duplicates in both sides. All right. So actually, maybe I'll do that in another video. But okay, that is how we can think about joining data sets together, which is another very useful tool in the Data Wranglers tool belt, something that you'll probably have to do a lot.